morning, my name is Joël Gossi. I am an Apigee expert. I'm working as a technical solution consultant. I will be your host today to present network patterns with Apigee X. So let's start. Apigee X is a managed solution, which means that Google not only managed the control or management plane, but also the runtime plane that is part of the Apigee X solution. So the complete solution is fully managed by Google. But this let also the possibility for our customers to define different type of ingress and egress solutions in order to consume APIs that are deployed and exposed on the Apigee runtime, but also from Apigee to consume different type of workloads. And this is what we will see in terms of network patterns in this presentation. Let's start with the VPC peering that is created between the Apigee X VPC and the customer VPC. When you provision Apigee X, one possibility is to enable the VPC peering between the Apigee X VPC, that is part of an Apigee tenant project provisioned during the provisioning time, and the customer VPC that is defined at the time of the provisioning. This VPC peering will give you the ability from an ingress to reach different APIs exposed on Apigee, and from Apigee to access different workloads on GCP, but also that can be hosted on different other locations like internet hosted workloads. Of course, this Apigee runtime is also able to communicate with the Apigee management plane, and on this Apigee management plane we can see that different APIs are enabled in order to propose different type of services like management services. This is what we call the Apigee API, a set of API that you can use to interact with the Apigee X solution, but also API analytics and developer portal, what we call the integrated developer portal. Of course, the Apigee solution, the Apigee X solution, can also play with different other Google solutions like cloud identity, cloud logging, YAM, identity and access management, and cloud monitoring, to mention just a few of them. So this is the big picture, the architecture of the Apigee X solution. Again, once the Apigee X runtime has been provisioned, it can be accessed through a VPC peering, and in this case, customers are responsible for defining different type of ingresses like external load balancer, internal load balancer, in order to be able to access the different API exposed at the Apigee level. From Apigee, it is possible to use this VPC peering to access different type of workloads on GCP through different type of egresses, but also to access internet hosted workloads and on-premise solution as well. Of course, these slides mention the customer VPC that is paired with the Apigee X VPC. But in real situation, a service project will be used in order to provision the Apigee X solution, and a shared VPC that is part of the host project will be used to be paired with the Apigee X VPC. In this case, all the different ingresses that are part of different service projects will be able to reach the Apigee runtime, and Apigee will be able to reach different workloads that are part of different service projects in the context of the same shared VPC. Again, in this situation, it's also possible from Apigee to reach internet hosted workloads. If enabled, it is possible to delete the route, to disable the route in order to not allow Apigee runtime to access internet hosted workloads if needed. Another possibility is to provision Apigee X with a non-VPC peering mode, but we will discuss this point later. If the non-VPC peering mode is used in order to provision Apigee X, it's not possible to use VPC peering. In that case, Private Service Connect will be used not only to access the Apigee runtime, but also from the Apigee runtime to be able to communicate with different workloads on GCP if this type of workload need to be used, like Cloud Run application, for instance. Private Service Connect can of course also be used in case the VPC peering has been set between the APGX VPC, part of the Tonon project, and a customer VPC. In that case, all combinations are possible. I can use Private Service Connect on the northbound from client application to consume API that are exposed on Apigee. And for instance, I can use the VPC peering to access workloads from Apigee on the southbound connectivity. If the non-VPC peering mode has been chosen to provision APGX, in that case, only Private Service Connect will be used in order to consume API and from Apigee to reach the different workloads. Let's discuss some other aspects of Apigee. First, I would like to also mention the fact that it's possible to reach from Apigee different workloads that are part of an on-premise infrastructure. In that case, an interconnect, cloud interconnect or cloud VPN communication can be used in order from GCP to reach backend services that are part of an on-premise infrastructure. As you can see on this example, the client application will use an ingress of type external load balancer as an example to consume APIs exposed on Apigee. And from Apigee, it will be possible to reach backend services through the cloud interconnect or cloud VPN connectivity to reach backend services that are part of the on-premise system. It's very common for customers to use this type of solutions in order to use their existing core IT services, mainframe as an example, or existing backend services that sits on-prem from Apigee, and to expose this backend, this legacy system as APIs on the APGX platform. Let's discuss a little bit about developer portal. When you work with an API management solution like Apigee, the developer portal is an important part of the platform itself. It will allow you to give access to different API products that have been created to your partners, for instance. And this is, again, a very important part of an API management program. So with APGX, the first solution you have is to use the integrated developer portal that is part of the Apigee management plane. This integrated portal gives the ability to deploy API product plus documentation, and app developer will be able to sign in on this developer portal and test directly from the portal the different APIs that are exposed at the Apigee runtime level. Another option in terms of developer portal is Drupal. Drupal is a CMS, content management solution, that can be used in the context of Google from the marketplace. You know, this is a CMS. Drupal is a CMS that you can find as a managed solution. In that case, the Drupal developer portal will communicate with the Apigee management plane in order to be able to get the list of API product, interact more specifically with the Apigee solution. As an example, if a client application is created at the Drupal developer portal level, this client application will be replicated and created also on Apigee in order, to synchronize this type of information between Apigee and the developer portal itself. Another option, in order to host the Drupal developer portal, is to use a service provider. And in that case, Drupal is managed by a service provider. It is exactly the same solution, but with a different type of management in this case. Just to mention that you can also create your own developer portal with a custom solution that will directly use the Apigee management plane and the Apigee management API in order to be able to interact with the APGX solution. So now let's deep dive into some detailed architecture. The first architecture I would like to present is single region. We have provisioned, in that case, the Apigee runtime into a dedicated region that we call region 1. We have created an Apigee organization. This Apigee organization is linked with one GCP project. There is a one-one relation between a GCP project, Google Cloud project, and an Apigee organization. What we call an organization is a tenant in which you can create API proxies, shared flows. You can deploy these API proxies and shared flows into some specific environments, and you can also create other type of objects like API products and so forth. So this is the Apigee organization, and this Apigee organization, one Apigee runtime, and this Apigee runtime has been deployed into one specific region. When you create an organization, an Apigee organization, you need at least one Apigee instance, one Apigee runtime to operate. But you can have several in case of multi-region. This is what we will see later with some other type of network patterns. In this pattern, I have one Apigee organization with one APGX runtime. This APGX runtime, as we have seen, can be reached using the VPC peering from the customer project that has been used to provision the APGX runtime and that has been used to define the Apigee organization. Here we are using an external load balancer, L7, HTTPS external load balancer, and through a network bridge VM, we are able to cross the VPC peering in order to reach the Apigee runtime. On the tenant project and in front of the Apigee runtime, there is an ingress L4 internal load balancer with a private instance IP that is the entry point, the ingress to access the Apigee runtime itself. When we create the VPC peering, we need a /22 range and a /28 range that are dedicated to the APGX runtime, to the APGX provisioning. In order, the /22 is used in order to scale on this specific IP range, and the /28 is used by the Google support team if needed to connect to the tenant project and install some specific VMs, virtual machines, on which some different tool will be installed in the case complex debugging needs to be performed to diagnose, to troubleshoot the Apigee runtime. So here we are in a situation where the external load balancer is plugged with backend service. This backend service is defined with managed instance group, some dedicated VMs into the managed instance group, and through these VMs operating at the level 3 level, so pass-through mode, this gives a direct access to the ingress L4 internal load balancer that can be used to reach the Apigee runtime. Okay, so from the external load balancer, I am able to reach directly the APGX runtime. From the APGX runtime, I can access different backend services like internet hosted workloads or on-premises workload. We will come back later on the southbound connectivity from APGX, from the APGX runtime to the different workloads. Here we are focused on the northbound connectivity from an API consumer to the Apigee runtime. So the first option is external load balancer to give an external entry point to the different client application, and through this external load balancer we are able to reach the APGX runtime with what we call bridged VM, so a managed instance group of VM, as I said, to cross the VPC peering and reach the APGX runtime. Another solution is to use private service connect. So with an external load balancer, L7 external load balancer, so HTTPS load balancer, we are able also to reach the Apigee runtime through a service attachment that is exposed on each instance of an APGX runtime. So when an APGX runtime is provisioned, has been provisioned, a service attachment is exposed. And you can use this service attachment in order to create a communication link based on a private service connect network endpoint group that will, through an endpoint, use the service attachment exposed by Apigee to create a communication link. And this PSC, private service connect network endpoint group, can be used from an external load balancer in order to give again an entry point to access the Apigee runtime. So here we have decided to add Cloud Armor on this external load balancer. Cloud Armor is a security solution that can be used in order to protect your API management platform from different types of attacks, like distributed DOS, for example. So this is something that is very commonly used by our customers in order to protect the APIs that are externally exposed. So this is another solution to here reach different APIs that are exposed on Apigee in a single region mode, as you can see here. Of course, it's possible to create a different type of load balancer here. We mentioned until now L7 external load balancer in order for client application, external client application, to be able to access APIs exposed on Apigee through this external entry point. But an ingress, some other ingress can be implemented, like the L7 internal load balancer, which is regional, but that can also be set with a global access. In that case, when the internal load balancer has been set, internal clients, internal to your Google customer Google project, can use this internal load balancer in order to access the same way that we described it before through a bridge VM, as an example, to access the different APIs exposed at the Apigee runtime level. In that case, I have here different type of API. Some of these APIs can be of type internal, some other of type external, some other can have both types, external and internal. In that case, I can operate a segregation of my APIs. Some APIs will only be consumed internally, some other APIs will only be consumed externally, and some others will be consumed internally and externally. I can decide that at the moment I create an API on Apigee, what we call an API proxy, I will be able to deploy it on some specific environment, and these environments will have an external or internal visibility, or maybe both internal and external. So this is also very common for our customers to operate with this type of visibility, internal and or external. Now from Apigee, of course, we are also able to use the VPC peering in order from Apigee to reach different type of workloads on GCP. If I have workloads, VM as an example, that are part of the customer project, I will be able, through the VPC peering and from Apigee, to consume these different workloads, as you can see here on this slide. In that case, I can use an internal load balancer, L7 internal load balancer, in order to access different workload VM, just to mention this type of workloads that can be reached from Apigee. I can also access our workload VM that are not only part of the customer project, but that can be part of different projects. These different projects will be paired with the customer project as we did the peering between the customer project and the APGX VPC that is part of the tenant project. But as you know, VPC peering is non-transitive. That's why I cannot here go from Apigee, cross the first VPC peering, and from here reach a workload VM through another VPC peering. I can do that only if I operate a termination here, in this case through some proxy VM, and in that case I terminate here the communication, and I can operate a new communication based on a new VPC peering. This is something very important to consider in the architecture. I cannot go directly from Apigee to a workload here in this case because the VPC peering is non-transitive. I can cross a first VPC peering, but I cannot cross a second VPC peering because of this non-transitivity. I cross the first VPC ring, reach a MIG proxy VM, which again operate a termination, first VPC pairing. Okay, now a second communication, completely different, another communication, and in this case I can cross the second VPC pairing to reach some other workloads that are part of some other Google project. In that case, I can differentiate dev and test, two different environments from which that I can use, and from Apigee I will be able to reach different VM on different environments. Another possibility here is to use, of course, L7 layer 7, internal load balancer, okay, and operate a routing, a load balancing here between different internal load balancer that are part of the customer project. And from this internal load balancer and through dedicated proxy, I can reach workload VM that are part of some other GCP project and use VPC peering in that case to reach these different workloads. Of course, Private Service Connect can also be used in order to reach the different backend system. Okay, in this case, as you can see on the picture, from Apigee, I have created here two PSC endpoints. At the Apigee level, you have this possibility to create Private Service Connect endpoint, and these endpoints are each attached to a service attachment, each in a different project, in order to reach different workload VM. In this case, I don't need VPC peering. I'm using here directly Private Service Connect, which is very convenient. So from Apigee, I create Private Service Connect endpoint, and these endpoints are attached in order to reach different workloads in different other projects. A dev project, a test project here. In that case, what is interesting again is that I don't need VPC peering. I'm using here directly the Private Service Connect type of connectivity. Of course, I can also here reach different backends, internet hosted backends, for instance, or on-premise type of backends. And what is also something very interesting is that I can create a cloud NAT here in order to go out of the Google environment with some specific IP addresses that can be controlled at the on-premise level, for instance. And this is very useful for IP whitelisting. If I want to be sure that the traffic is coming from a very specific set of IP addresses, I can control it, as I can set cloud NAT here on the egress of my Apigee organization here. Other patterns here, again for single region, where I can use here, as you can see, PSC Private Service Connect to reach here, my Apigee runtime, and I can do this from different Google projects. This is also something extremely interesting. I don't need again VPC peering in that case. So here I've got an ingress L7 global external load balancer that is defined with a Private Service Connect network endpoint group, and this gives me an access to the Apigee runtime. I've got here another ingress L7 global external load balancer, another load balancer that is part of another project, and using the same technology, Private Service Connect network endpoint group, I can reach the Apigee runtime. So different load balancer with different Private Service Connect endpoints that are part of different GCP projects can be used in order to reach the same Apigee runtime. And this is possible without VPC peering because we are using here the private service type of connectivity. And on the southbound communication from Apigee, again, I can create a service endpoint, a Private Service Connect endpoint, and use this endpoint in order to reach a workload that will be part of another project, a completely different project. And this is something very, very useful and very convenient for our customers. In some situation, they are working with different teams working in different GCP projects. This thing, as an example, can at one moment produce a workload, let's say a Cloud Run application that is critical and that needs to be exposed to external partners. As an example, using PSC, it will be possible from Apigee to reach these specific workloads and to expose them as an API directly at the Apigee level. So this gives a lot of flexibility in order to reach different workloads in different GCP projects without the constraints of, for this project, to be part in terms of VPC connectivity, to be part of the same VPC peering, because in some situation VPC peering is not used. In this type of pattern that we can see here on the screen, it's possible, to use Private Service Connect. Of course, if VPC peering has been enabled, okay, this is something completely different, but also if the non-VPC peering mode has been used in order to provision Apigee. Automatically, if the non-VPC peering mode has been used to provision Apigee, your Apigee runtime, automatically you will need to use PSC, Private Service Connect. If the VPC peering mode has been used to provision Apigee, you have the choice to use VPC peering and or Private Service Connect on the northbound and southbound. And as the example that I gave before, you could enter your you could consume your API using Private Service Connect on the northbound, and from Apigee use the VPC peering connectivity to reach different workloads that are part, for instance, of the customer project. And you see here two types of communication. The first one northbound based on PSC, the second one southbound based on VPC peering. You have this flexibility when VPC peering has been used to provision APGX, which is not the case when non-VPC peering mode has been chosen. In this case, you must use PSC in northbound and southbound. Okay, let's go into multi-region type of patterns. So here we have two regions, so an Apigee organization with two instances, the first one in region 1, the second one in region 2, automatically. You cannot have in one Apigee organization two instances deployed in the same region. Automatically, instances, the runtimes, the APGX runtimes will be installed in two different regions. This is something important. Of course, these two runtime are part here of the same Apigee organization, which means that when I deploy an API proxy on an environment, if this environment has been distributed on the two regions, the API will be accessible from region 1 or from region 2. Okay, and I will have here a load balancer in front of the two instances with Cloud Armor, eventually, that will distribute the load on one region or the other, based on, as an example, on the client application location. If my client application operates in region 1, the global external load balancer will use region 1 here, and the region 1 Apigee runtime will be used to execute the API traffic. If the client application sits in region 2, the region 2 Apigee runtime will be used, and of course, the global external load balancer will decide which region to use based, in that case, on the client application location. That's something important. Here we are using bridged VM in this situation in order, from the global load balancer through the different backend services that have been defined, the first one in region 1, the second one in region 2, different type of backends of type MIG, Managed Instance Group in this case, MIG with dedicated VM, in order to be able to communicate with the Apigee runtime through the VPC peering, as we have seen. In that case, health check is possible. That's something extremely important. The different instances here can be health checked, which means that if an Apigee X runtime in one region crashes, as an example, the health check will detect that this runtime is not accessible anymore, and all the traffic will go through the other region in order, to assure high availability in this case. That's something super important. So health check here is executed in order to control the life of the different Apigee runtime instances. And again, if one runtime crashes, the traffic will go through the other one. Otherwise, there will be a load balancing, of course, of the traffic between the two runtimes regarding the location of the client application, as an example. As I said, the different environments that you create on Apigee can be distributed on the two regions, on the two APGX runtimes, in order to be able, when an API proxy is deployed on these environments, to be able to execute exactly the same set of policies on your API traffic. This is something extremely important. Regional health check here can be also done. So here we another situation. We have an ingress L7 external load balancer, and the possibility here, to perform health check with an ingress of type internal load balancer that is regional. Only here, one region will be accessible, except if global access has been set for this internal load balancer. Again, here a view with the different environments from the same Apigee organization distributed in the different APGX runtime instances. PSC can also be used on an ingress external load balancer in case two regions are part of the Apigee organization. Okay, the only limitation we have here is health check. Health check is not available yet on backend of type network endpoint group, which only outlier detection can be used in this case to detect errors that occurs at the Apigee runtime level and operate a load balancing of the traffic on one specific region if needed. So health check is not yet available, but this is something that should be available in 2025. For this, I will encourage you to follow the roadmap, networking roadmap specific to Apigee, in order to know when a preview and GA will be announced on this new capability. Hostname rules in a URL map, that's also something possible in order to create a URL map at the load balancer level. And with different hostname, you can, of course, define different backends that you want to reach. So this is something that can also be done at the load balancer level. Hostname rules in a URL map in order to simply route the traffic to on one APGX runtime or the other, on one region or the other. External access and internal access. In case of multi-region, as you can see, you can have an ingress of type L7 global load balancer that will spread the traffic between two regions through managed instance group, here as an example, and an ingress L7 internal load balancer, in that case, that will also be able to route the traffic on one region or the other for internal clients in this case. Okay, so this is something extremely interesting, because again, in this case, you have much more availability than with one region. With one region, if the region fails, your traffic will not be able to be executed, your API traffic. If you have two regions, the SLA is better. You have 99.99% of availability versus 3.9 in case of a single region. So in that case, not only for external but also for internal traffic, you can assure high availability, which is something very common in production. In Apigee production organization. Let's focus on APGX to GCP services. So now here we are going to focus on the southbound connectivity from Apigee to the different workloads. The first pattern here is from Apigee, the possibility you have to access different backend services through an HTTPS global load balancer. In that case, CloudNAT can be used, and you can control the IP address with IP whitelisting to be sure that your traffic comes from the Apigee runtime at the workload level through the control that you have at the global load balancer level. Again, you can control the fact that the traffic comes from a specific set of IP addresses, so that's something possible in this case. If you keep in the Google Cloud network, in that case, you have different possibilities in terms of backend. So here we have an external load balancer, just to quickly describe the northbound connectivity that give access to different regions, two different APGX runtime instances. And from here, you want to access some Cloud Run application. Of course, in front of your Cloud Run application, you may have an internal load balancer in order to control here, as an example, the different certificates that are used to access these Cloud Run applications. And so from here, if the internal load balancer have a global access, this internal load balancer can be accessed not only from the API in the same region, but also from an Apigee runtime that has been instantiated into another region. So here the regional internal load balancer, for example, in region 1, can be accessed by Apigee in region 1, but also by Apigee in region 2. The same for the other regional load balancer that has been implemented in region 2. Okay, with global access, not only APGX runtime in region 2 can access this internal load balancer, but APGX in region 1 can also access this regional load balancer. So you can define here a different target endpoint with different target server. I would say a common way of accessing the regional load balancer in region 1 is from API proxy here with a target server plugged to the internal load balancer in region 1. But in case there is an error here, the regional internal load balancer cannot be accessed, in that case, the second target server is used as a fallback to access the regional L7 internal load balancer in region 2, and vice versa with the APGX with the API proxy configuration on region 2. So the two API proxies deployed on region 1 and region 2 have exactly the same configuration, but the routing between one target endpoint or the other is done through system.region.name, which is an internal variable on Apigee that you can use in order, again, in that case, to route to one target endpoint or the other. Again, the same API proxy, the same configuration is deployed on the two regions here. So we need, this to use this specific context variable in order to route the traffic to target endpoint 1 or target endpoint 2 as described. Another type of internal application load balancer can be used, which is the cross-region internal application load balancer, which is very interesting because in this case, we are going to see here the detail of such load balancer. In this case, when you reach the internal load balancer, as you can see here, you reach a target proxy global, a URL map that is global, a backend service that is global, and that will also here operate a routing on two Cloud Run applications. And if one Cloud Run application fails, cannot be reached, the other one will be used. So you can enter here, for instance, on API proxy on region 1, because the traffic has been routed on region 1 from the external load balancer. And from here, you can reach, as an example, the load balancer through the cross-region internal load balancer capability. You can reach here the load balancer subnet in another region, but use the Cloud Run application that is part of the other region, region 1, because, as an example, the Cloud Run in region 2 would not be accessible at one moment, as an example. So this is something very interesting because you have load balancing capabilities at each level, at the API proxy level and also at the internal load balancer level to reach the Cloud Run application that is available at one precise moment. Another example here using PSC endpoint. So on the previous example, just to mention this fact here, we used here VPC peering. We consider that we are using VPC peering with different workloads that are part of that are attached to the customer VPC, part as an example of the customer Apigee project, the project that has been initially used in order to implement and create the Apigee organization. In these new examples here, we are using customer non-Apigee project. As you know now, you can use Private Service Connect in order to reach Cloud Run application, as an example, deployed into a project that is completely decorrelated from the Apigee project. So you don't use VPC peering in this case, but automatically we are using here Private Service Connect. So Private Service Connect endpoint at the Apigee level, attached to private service attachment in front of a regional L7 internal load balancer with global access. And this can be used, of course, to reach the Cloud Run application. Okay, if this regional this regional load balancer can be accessed not only by the APGX instance in region 1, but also by the APGX instance in the other region, because it has a global access. Okay, and in this case, again, you can create a load balancer group at the Apigee level with a fallback in case the target server cannot reach the PSC endpoint, attachment, and internal load balancer in the same region. The other target server is used as a fallback to reach the other internal load balancer with the same global access, but in the other region to reach the Cloud Run application. So that's something very convenient in this case, and here it is completely based again on Private Service Connect. The only limitation here is cross-regional internal application load balancer. The PSC attachment is regional, so it's not possible to use PSC attachment to reach an internal load balancer that is cross-regional internal application load balancer. So this is a limitation. I hope you found this presentation useful, and I wish you a very good day. Bye.